Okay, in this video we're going to take a look at stereoisomers, and what we have seen is that there are more than one type of stereoisomer. Isomers in general can be broken into two categories: constitutional isomers and stereoisomers, and then there's a few different examples here. This video will be looking just at these, cis-trans isomers. Let's have a look at a few examples. Here's a few examples of cis-trans isomers. I should point out that in our course, the only examples we will look at of cis-trans are the cis-trans isomers that occur in alkenes. It's possible to have cis-trans isomers with cycloalkanes, and we will not be looking at that, only alkenes. So here's what we want to notice. Alkene, of course, has a double bond and double bond. What we will look at, we'll highlight the parent chain and take a look at the geometry around the parent chain. Here's the double bond. The group coming off the left is pointing down, and the group off the right is pointing down. They're both doing the same thing, going down. As opposed to this example where the one on the left is pointing down, the one on the right is pointing up. They're doing opposite. Here the two ends of the parent chain are doing the same thing. They're both going down. Here the two ends of the parent chain are doing the opposite thing, one up, one down. This is an example of a trans isomer. This is an example of a cis isomer. And I should point out, if we wanted to, we could have written it like this. There's nothing special about them both pointing down. What defines something as cis is that the two ends of the parent chain are doing the same thing, either both up or both down. One up, one down, or, again, that's trans as well. Cis and trans happens sometimes in alkenes. Here's another example. What you should be able to do is right away identify if it's cis or trans. These ends of the parent chain are both going up. This is cis, and this one is trans. They're both hexene. They both have the double bond on carbon 3. If we were to number those, we would see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So both of these are 3-hexene. This would be cis 3-hexene, and this would be trans 3-hexene. One more example. This is not one we're going to name, but I'd like you to notice that in compounds that have more than one double bond, then there's more than one chance to have cis-trans. This is an example of a molecule in your eye. This is called retinal, and it comes in it can have cis-trans isomers, and if we look carefully, that's the same for both. That double bond is the same for both. This double bond, though, take a look. Here, right here, it looks like this is in the cis form, right there. And here, that same bond is in the trans form. Cis and trans. This double bond is trans. This one is trans, so there's more than one double bond. We're looking at that one and noticing cis and trans. This, in fact, is what happens when light hits your eye. It gives enough energy to flip from back and forth between cis and trans, and that is how your eye can respond to a light hitting it, a cis-trans flip. So, cis and trans, when it's simpler examples, we want to be able to name them. More difficult ones, of course, not, but I'd like you to notice that cis and trans isomers happens frequently with alkenes. So to close this video, let's see what we just did. We're talking about isomers. There are two categories of isomers, constitutional and stereoisomers. We just did the first type of stereoisomers, cis and trans. Now let's take a look at the second type, enantiomers. This one actually is broken into a couple different videos. This is a trickier, more complex topic, but we will take it bit by bit.